Welcome to Savi YouTube channel created by Sai Vidya Institute of Technology. I am Dr.T.G.Manjunath, HOD, Department of EEE. The last few sessions we have started with the Millman's theorem. So we proved this theorem, and the concept of the theorem is if n number of voltage sources are connected in parallel like this entire network or the combination can be converted into a single voltage source in series with a impedance. This is the concept of the theorem. So whenever n number of voltage sources are like this, then if you are going to convert this into single voltage source in series with the impedance just by using a simple formula. So that we proved in the last class. Today let us solve the problems. Before solving the problems, so what formula we have to make use of is, suppose if the network consisting of 3 AC voltage sources, 3 sources, then what is the single voltage source value? How to write the formula? If the network consisting of 3 AC voltage sources in parallel, then the single voltage source Vs can be written as E1 Y1 plus E2 Y2 plus E3 Y3 divided by Y1 plus Y2 plus Y3. Here E1, E2, E3 represents the voltage source values. Y1, Y2, Y3 represents admittances of these voltage sources. Y is nothing but here admittance. So where Y1 is equal to 1 by Z1, Y2 equal to 1 by Z2, Y3 equal to 1 by Z3. So inverse of impedance is admittance. This is Z1, Z2, Z3 is nothing but impedance which is connected in series with the source. Then how to find this impedance Z? That impedance Z is given by 1 divided by Y1 plus Y2 plus Y3. That's all. Just you are going to make use of the formula. Suppose if the network consisting of 3 DC sources, if DC sources comes here DC, then we are not going to represent by impedance, we represent by resistance. So let it be R1, R2, R3. So assume that 3 AC voltage sources are in, DC voltage sources are in parallel. So here we are going to represent by resistance, internal resistance of the source. Then we are going to convert this into single voltage source DC in series with a single resistance, in series with a single resistance. So in series with a resistance. Now how to find this Vs value and the resistance value? Again formula remains same, only change is here instead of admittance we should write conductance G. Therefore the formula becomes for DC sources, the formula becomes Vs equal to E1 G1 plus E2 G2 plus E3 G3 divided by G1 plus G2 plus G3. What is G here? It is the conductance inverse of resistance. So where G1 is equal to 1 by R1, G2 is equal to 1 by R2 and G3 is equal to 1 by R3. That is how to find the single voltage source value. Then the resistance, series resistance is given by 1 divided by the same thing. Instead of Y we should write G, that is G1 plus G2 plus G3. So this formula if you just make use of, you can solve any problem on Millman's theorem. So this formula is for AC sources, this formula is for DC sources. Now let us work out some problems on this Millman's theorem. Okay, the problem is find the current flowing through the load resistance using Millman's theorem. So Millman's theorem is applied whenever the voltage sources are in parallel. Now you can see this network. We have 3 DC voltage sources connected in parallel, and this is the load which is given here 10 ohm. Our intention is to find the current flowing through this load resistance. So using Millman's theorem, if n number of voltage sources are in parallel, you can convert this into single voltage source. So let us write the data. So E1 is equal to how much? 20 volts. So E2 40 volts, E3 50 volts. This is what voltage source. Next, this is R1. So R1 is 2 ohms, R2 4 ohms, R3 5 ohms. Okay. Next, what I should find? Conductances. G1 1 by R1, that is 1 by 2, that is 0.5 mho. G2 1 by R2, that is 1 by 4, that is equal to 0.25 mho. The unit of conductance is mho. Then you have to find G3. G3 is what? 1 by R3. So 1 by R3, 1 by 5, that gives 0.2 mho. So according to Millman's theorem, the single voltage source is given by Vs equal to E1 G1 plus E2 G2 plus E3 G3 divided by G1 plus G2 plus G3. Now you know all the data here, E1, E2, E3, you know, G1, G2, G3, you know, just substitute here and find the value. Directly you can substitute here and find the value using the calculator. You will get the value, please check it, how much you will get. Now if you substitute all these values and if you enter in calculator, you will get the answer as 31.57. Okay. Next, what you should find? You should find the value of R. What is R? 1 divided by G1 plus G2 plus G3. Okay. Put the bracket when you are entering in calculator. So substitute here G1 value, G2 value, G3 value here and calculate all of you. What is the value? You may get 1.052 ohms. This is value of the R. So you got the value of single voltage source, you got the value of resistance. Then what you should do? Your intention is to find the current. Now in place of this, let us write a single voltage source Vs in series with R. Then keep this load as it is here. So you know the load value 10 ohms. Okay. You know this value, you know this value. Now find the current here just using Ohm's law. So load current is equal to what? Vs divided by R plus RL. R plus RL. Okay. Vs you know, R value you know, RL value you know. Substitute here, you will get the value of load current. So if you calculate the value of load current, you will get 2.856 ohms. So such a simple problem it is on Millman's theorem. So let us work out one more problem. It is very simple, just you have to make use of the formula. Now let us solve another problem. Find the current flowing through the load resistance using Millman's theorem. So this is the problem given. Your intention is to find current flowing through this load resistance. So Millman's theorem is applied only whenever the voltage sources are in parallel. If there are any current sources, you have to convert it into voltage source. Then you can apply that formula to solve the problem. So you have a voltage source here, but you have one more current source. Hence, first let us convert this current source into voltage source. So V is equal to I into R. What is I here? 5. This is 4. So 5 into 4 gives 20 volts. So I am going to replace this by 20 volt source in series with the same resistance, that is 4 ohm. You know how to convert current source into voltage source. Now, so V is equal to I into R. Current value is 5, resistance value is 4, it gives 20 volts. So in series with the same resistance I should write. When you are writing the voltage source, you should write the polarity. Polarity depends upon the direction of current. Okay. Since arrow is upward, when I am writing the voltage source, positive should be written upward, negative downward. Okay. Let us rewrite. In place of this, I will write a voltage source here. So resistance in series with a voltage source. So positive is upward, down negative, 20 volts in series with 4 ohm. Now we have 3 voltage sources in parallel. Let it be the terminals A and B for your reference. Now let us write the data. Before writing the data, so formula you know, this is the formula to convert this into single voltage source, which is given by Vs equal to E1 G1 plus E2 G2 plus E3 G3 divided by G1 plus G2 plus G3, because this is a DC source, DC network. Now let us write the data here. Data, what is E1? E1 is equal to 4 volts. So very important is polarity. Earlier when we proved the theorem, we have taken the terminal A as positive, B as negative. So but here it is opposite. Therefore I will write here the polarity for E1 as negative, that is I will write here as -4. Similarly E2 also -8. E3 I will write plus 20 because A is positive here. So E3, let it be plus 20 volts. This is the data, very important. Previous problem, all upper terminal is positive, lower is negative, but here it is reverse. Hence I am taking this as -E1, this as -E2, which is plus E3. Next, after writing this, write the resistance here. What is R1? 2 ohms. R2, this is 3 ohms. So R3, it is equal to 4 ohms. Then what I should find? I should find G1, G2, G3. So G1 is what? Conductance, inverse of resistance, that is 1 by R1. What is 1 by R1? 1 by 2, that is 0.5 mho. So what is G2? G2 is equal to 1 by R2. What is R2 here? 1 by 3. 1 by 3 is 0.333, or else you can substitute directly in the formula 1 by 3. So if you do like this, if you get more fractions, then you may not get an accurate answer. If you want accurate answer, you substitute as it is. It is 1 by R1, 1 by R2, 1 by R3. Substitute the value, enter in calculator, so that you will get exact answer. So G3 is what? 1 by R3. What is R3? 4. 1 by 4. 1 by 4 is 0.25 mho. Now you got all the values, just substitute here. So Vs is equal to E1 G1. E1 G1, that is -4 into 0.5 plus E2 G2. E2 is -8. So -8 into 0.333. Okay, plus E3 G3, that is equal to what? 20 into 0.5. Okay. Since these two are negative, you can directly write this as negative. Okay. Next, divided by G1 plus G2 plus G3, that is equal to 0.5 plus 0.333 plus 0.25. Okay. Enter this in calculator, find the value of voltage source value. Check the answer. Answer as 0.311 volts. So if you want exact answer, you can do one thing, you can substitute as it is here. E1, G1 is what? 1 by R1 plus E2, G2 1 by R2. So then substitute the values of R1, R2, R3. Similarly here also, 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the value, enter in calculator instead of doing separately like this. so that you will get exact answer. Next, what I should find? I should find the value of resistance. What is the value of resistance? 1 divided by G1 plus G2 plus G3. You know G1, G2, G3. Substitute. Find the value of R now. Answer as 0.923 ohms. This is the value of R. That means you have converted these three voltage sources into single voltage source. Now, let us rewrite the circuit. So, I am converting these three voltage sources into single voltage source and keep the resistance, load resistance as it is. How much it is? 5 ohms. Our intention is to find current flow now. Current flow, that is load current. So, load current IL is equal to what? Vs divided by R plus RL. Okay. So, you know Vs, you know R, you know R by RL. Substitute here, you can find the value of load current. That is what? Just by using Millman's theorem. Now, let us check the answer. What is the answer for RL? 525 ampere. This is the load current. So, this is how to solve the problem by using Millman's theorem. Means, if any current sources are there, please convert that current source into voltage source, then substitute the values, find the current. This is how to solve the problem for DC sources. If AC source is there, only in the formula replace G by Y and substitute, do it. But when you are entering in the calculator, you should be very careful, otherwise you will get wrong answer. Now, let us solve one more problem on Millman's theorem for AC network, which is asked in VTU examination. Your intention is to find Vs, that is the voltage at this point, using Millman's theorem. So, you have three voltage sources connected in parallel and it is a AC network, and the values are given here. You know the formula using Millman's theorem. So, the single voltage source Vs is given by, for AC network, it is E1 Y1 plus E2 Y2 plus E3 Y3 divided by Y1 plus Y2 plus Y3. Okay. Here E1, E2, E3 is nothing but this only, that I can take this as E1, take this as E2, this is your E3. Now, you know E1, E2, E3. Next, what I want? Y1, Y2, Y3. To find that, first you should write here impedances of these sources. So, this is Z1, this is Z2, this is Z3. What is Z1 here? J20. Z2 is what? Minus J20. Z3 is what? That is just it is 20 ohms. Okay. Next, you should know Y1, Y2, Y3. So, what is Y1? Y1 is 1 by Z1, Y2 1 by Z2, Y3 1 by Z3. So, you have to substitute there. If you want, you can write separately, you can calculate separately, or else you can substitute directly. Suppose if you take separately here 1 by J20 na. If you want, you can take J to the numerator with opposite sign. So, if you take J to the numerator, it becomes minus J. 1 by 20 is how much? 0.05. Okay. So, what is Y2? 1 by minus J20. Take J to the numerator with opposite sign. It is minus J20. If you take, it becomes plus J. 1 by 20 is what? Same, 0.05. Similarly, what is Z3? 20. 1 by 20 is how much? It is just 0.05. Okay. Now, you got it. Now, just you have to substitute here. Let us substitute here. So, E1 Y1. E1 Y1. Okay. So, 220 into minus J 0.05. So, this is polar form, this is rectangular form. So, a calculator will accept both the forms. Calculator will accept both the forms. Either you can enter a combination or you can convert both into polar form or rectangular form. Since calculator will accept both the forms, just you have to enter here and find the value of Vs. Now, suppose if you want this in polar form, you can easily write for this, since it is J, how you can write it here is, if you want this in polar, okay, this is now in rectangular form. J means what? 90 degree. So, 0.05 at an angle, it is minus J, no, you can write minus 90. Similarly, this is 0.05 at an angle plus J, it is plus 90. Only for J you can write. Then here no J, just keep it as it is. So that you can enter these values here and you can solve. So when you are entering in the calculator, so put the brackets properly. Put the brackets here properly and substitute these values in this formula and find the value of Vs. Okay? Find the value of Vs. So now I have substituted the values of E1 and Y1 here, E1, Y1, E2, Y2, E3, Y3 and Y1, Y2, Y3 I have substituted. So when you are substituting and you enter in calculator, you should put properly brackets like this, and denominator admittances I am adding, I have substituted in a rectangular form only, that is this form only. You can substitute in this form also. So why I have substituted here is, you can cancel these two, so that divided by 0.05 if you do, you will get the answer for single voltage source as 168.36 at an angle minus 60. So this is in now polar form. Usually final answers we have to keep it in polar form, or you can keep in both the forms for the examination purpose. First you express in a rectangular form, that is in J form, then you can express in polar form, because calculator will give answer in both the forms. Then this is what your intention, to find the single voltage source value, and if you want to find the impedance of that voltage source, so Z is equal to 1 divided by Y1 plus Y2 plus Y3, that is equal to 1 divided by, so here Y1, this is Y1, this is Y2, this is Y3, we are adding these three. If you add these three, these two get cancelled like this, divided by what you will get? Only 0.05. So these two get cancelled, you will get 0.05. 1 by 0.05 is how much? 20 ohms. That is how you are converting all the three voltage sources into single voltage source. So that is what you are expecting here. So finally, you are getting what? A single voltage source like this, in series with the impedance. So Vs in series with Z. Okay. So this is your ground. This is say terminals. So Vs value is how much? 168.36. What is that value? That is equal to 20 ohms. So three voltage sources were there. They are converted into single voltage source using this Millman's theorem. That is the advantage of this theorem. Just for the sake of understanding, I have solved 3 problems. In the same way, you can work out some more problems for AC network. Okay, thank you very much.